Hey everyone! So someone on Facebook in a group I'm following asked the following question. Hi guys, I'm trying to make a tree fall in the opposite direction of the collision, something like how tree behaves in WOT, without using physics. I know how to get the fall direction, but I'm struggling with values in quaternion LORP to make the tree rotate in the direction it should fall. And yes, I already tried to Google Stack Overflow, etc. and found nothing useful, or maybe I just don't know how to narrow my search. Anyway, help will be appreciated. Thanks in advance. So I thought it was an interesting exercise to kind of delve into the how to use rotations. And a lot of the time, people actually are a little bit afraid of quaternions. And it's just, you have to think of quaternions as rotations around an axis. And so you can interpolate between an initial rotation, which is the current rotation of which this little cylinder here, which is our tree, and a target rotation. And so the whole thing is going to be about how to determine the target rotation. So what the person means by I know how to get the direction of the rotation is because he knows. So let's go here and add a little bit of debugging here so that I can show you. So he knows, I set up this little scene with little cannons that shoot bullets from different side directions. He knows that when he shoots a bullet, he can get this vector here, that green vector that you can see, which is, oops, let's focus on this tree, which is the normal of the collision. So you can get that. I'm going to show you how to get it. That's the normal of the collision. But what we want is to find this little vector here, which is going to be the axis of rotation of the tree. And as you can see, this thing is actually perfectly perpendicular to both the collision normal and the up vector of the transform. So how do we do that? We do that by using vector3.cross. So let's have a little look at the code here of my tree rotator script. First of all, I have a rotation time that says how long it takes for the tree to rotate. So right now it's a bit flat, right? It's a linear interpolation. It's not very lively. You can change that in the code later on, but what's important is to understand the idea behind it. I have a little boolean that says can it rotate or not. This is just there so that if it is being rotated by one collision and another collider comes in and touches the tree, it doesn't start rotating in weird directions. And I save the initial rotation of my transform in this initial rotation thing. I also have a little useful method, reset rotation, to actually reset the current rotation to its initial rotation and reset the can rotate. But this here is where everything happens on collision enter. So the first thing I do is to get the collision normal. So to do that, you just need to get the collision. You can do the average of each contact's normal, or you can just take the first contact, depends on how precise you want to be with this. So you do get contacts.normal. And then the rotation axis, that one is going to be this vector3.cross, so which gives us a vector that is perpendicular to both the transform up direction and the collision normal. So that was our red vector in the scene. So this is just for a little bit of debug to show the different vectors. And then we need to determine what the angle of rotation is going to be. Now we could just say 90 degrees, but there could be situations where 90 degrees would actually be the wrong direction of the tree. So we want to see what is the signed angle between the collision normal and the rotation axis around the transform.up vector. So this will give us the angle, well, the angle between the rotation axis and the collision normal, which actually is going to be 90 degrees. So I don't know why I'm doing this 90 degrees time math sign. Oh yes, I'm doing that because maybe you don't really want to rotate it exactly 90 degrees for some reason. So you can actually kind of customize this. And then here comes the important thing. So we have our rotation angle. And now we want to calculate a new rotation that's going to be the target rotation of our tree. And we're going to use angle axis, which is a quaternion method that returns a quaternion. And that quaternion is the result of rotation angle degrees around the rotation axis. And once we have that, well, all we need to do is to start interpolating. So we call this little coroutine that goes and rotate our tree in the target rotation. So here I just have this little test. If it can rotate, then we do rotate. If it cannot rotate, then we don't do anything. Then I'm just gonna initialize how far are we in the completion of the animation, how far we are in the elapsed time, and then the time it will take to complete, which is going to be rotation time. I have no idea why I actually do this. Oh yes, I used to do a rotation speed before. So this, I'm just going to change this to rotation time. I don't have any checks there. I don't have any checks to see if rotation time is equal to 0, which would actually become a little bit of a problem. But I think if it's 0, this is just going to resolve to infinity, and so the minimum is going to be 1, and we'll just have an instant rotation, something like that. So while percent complete in our coroutine, well, we first add delta time to the time elapsed, then we go with the percent complete, we calculate it, we make sure that it doesn't go over 1. I think you could just you could actually make it go beyond 1. Then you'd have to use LORP raw, I think, or something. LORP. I think there's a LORP raw method that will only LORP until 1. LORP. Oh yeah, no, it is already clamped by default, actually. So I don't even have to do this min thing. Oh yeah, I know why I want to do this. I want to do this. No, yeah, I don't know. I don't know why I do this. Anyways, then we actually apply to the transformed rotation the linear interpolation with a certain percent of completion between the initial rotation and the target rotation. And then we just skip a frame and do it again and again and again. So let's see this in action now. First, I'm going to disable the debug here in my tree. I have a rotation time of 1. And also, just to show you, I have a little input controller here. It's very simple, kind of cool script that allows me to bind key codes to Unity events. And then that's how I actually action my cannon and I reset my tree. If you're interested to know more about that, I can talk about it in another video. So let's do play, right? And let's have actually from the top view here, the top view of our tree, so we can see that it falls indeed in the correct direction. So we have our 4 cannons. Cannon 1 is here, cannon 2 is here, cannon 3 is here, and cannon 4 is there. They're all directed to the tree. And if I press 1, I'm going to shoot with my first cannon. Bam. And indeed, you can see that our tree falls in the right direction, and it takes him 1 second. I press space, and I reset the rotation of my tree. Let's shoot with the second cannon, and indeed, the tree falls in the right direction again. Third cannon. Let's shoot. And fourth cannon. And there we go. So that's how you solve this problem. It's pretty interesting, and I definitely encourage you to look for more stuff into quaternions, because they're not really that scary. People tell you they are, but it's not that big of a deal once you start working with them. Hope you enjoyed it, and see you maybe in another video.